So we're going to start off with functions and relations. Now, we did this in grade 10, so it's been a while, but hopefully this is a quick review and it comes back to you once I go through it. Now, we're going to start with the definition set. Set is a group of items that are all connected. So all the x coordinates are a set. All the y coordinates are a set. Now, these ones are easy to see because there's a circle around each set. This one, set 1, the x coordinates are the first number in the ordered pair. Set 2 is all the y coordinates. For a table, set 1, set 2 is right there. An element is one item inside the group. So A is an element of set X. Relation is any time we have ordered pairs or things connected to each other. Everything in this set has to be connected to something. Now this one is not connected, but it doesn't matter. As long as set 1 or the x coordinates have a matching partner, that's all that matters. Here, everything in set 1 has a partner in set 2. Now a function is a special relation. This is where everybody in set 1 only has one matching partner. So you can see here, A only has a match to 2. B is only matched to 3. I always look at it as cheating. Nobody in this group is cheating. We don't really care about Y. As long as the first set, there's no cheaters. If we look at this one, if I cover up the set 2, I can see right away there's 2 3s. So I'm going to ask myself, is 3 cheating? Is 3 connected to 2 different elements? We can see it's connected to -2 and +2. This is just a relation. All of these are relations. This one, everybody has one partner. It is a function. Take a look at this one. What do you think? Take a look at set 1. Is there any repeats? And you can see right away, Calgary's twice, Edmonton's twice. Then if we look over, Calgary's connected to 2 different teams. It's a relation. So function is special. There's no cheating in the first set. Now the last part is one-to-one functions. We need to make sure this one is special functions where there's no cheating in the first set or the second set. So let's go through it. First of all, it's a relation. We can see everyone in here has a connection to set 2. To see if it's a function, we check for cheating. There's one line out of every single number. It's a function. To see if it's a one-to-one function, we check if, oh, wait a second, 32 is connected to 2 different numbers. Because 32 is cheating. This is a function, but it's not a one-to-one function. It doesn't work both ways. Take a look at the next one. Set X, there's 4 numbers. Each one has one line. It's a function. If I look on this side, there's 4 numbers, 1 arrow in each section. This one is a one-to-one function. So there's no cheating in both directions. So this one has empty spots, so I'm going to add some numbers. So is this a relation, function, or one-to-one function? So immediately I see there's 3 3s. So I'm going to jump to the conclusion and think there's cheating, but the first 2 are with the same number, 3 7 3 7. So there's no cheating there. The third one, there's cheating. So this one has to be a relation. 3 is with 2 different numbers. It's connected to 2 different places. Okay, so a quick recap. A relation, we can have cheating. It's okay. They can have as many relationships as they want. A function is special. We focus on the x side of things. As long as the first coordinate is not cheating, it's okay. It doesn't matter what the y is doing. And the third one, one-to-one function, is the really special one. There's no cheating on either side. Nobody has connections to 2 different elements. So if we have a graph, we're going to use something called a vertical line test. So let's take the graph of a oval. So I'm going to take a pen or a ruler and I'm just going to slide it across the graph. Now you can see here the line touches two different points. This makes it a relation. It has failed the vertical line test, it's just a relation. Now if it passes, this is an example, I can take this line and I slide my pencil any direction. I never touch two or more points. This passes the vertical line test, this is a function. Now to check if it's a one-to-one function, I'm going to change the vertical line to a horizontal. And I see, oh, it fails the horizontal. So it's not one-to-one, it's just a regular function. To be one-to-one function, we need it to pass both the vertical, like this one here. I have a curve that goes up like this. And I take my vertical line, which is right here, and I just slide my pencil back and forth. I never touch 2 points. The horizontal line, up and down, I never touch 2 points. So if it passes both vertical and horizontal, one-to-one function. So I want you to pause the video. On the next page, I want you to look at the 6 graphs, and I want you to write down, is it a relation, function, or is it a one-to-one function? Pause the video, then try it. Okay, so starting with this graph, I take my line, or ruler, and I slide it across, and I'm touching 2 points. Almost everywhere, I'm touching 2 points. Relation. This one, I slide it over, I'm touching one, I'm always touching 1 or even 0. And to see if it's a one-to-one function, it never fails the horizontal test. So if it passes the vertical, then check horizontal. This one here, I slide it across and I'm only touching 1 point. It's a function. I slide downwards and I'm only touching 1. This one passes the first vertical test, but fails the second one. So this is just a function. It only passed the vertical line test. And this one passes the vertical, passes the horizontal. And it may look a little tricky here, but it's always going down a little bit. And it looks almost horizontal, but it's not, only if it goes back up or goes straight across. This one passes the vertical, fails the horizontal. This is just a regular function. Okay. Now the next part is a little bit harder. If you ever have one and you don't want to do the work of graphing it, a quick easy way is if you have a y squared or a plus minus in the equation, it's going to be just a function. Or sorry, if it has a y squared or a plus minus, it's a relation. So let's look through here. Here we have an y squared. Immediately, it's a relation. To be a function, it can't have either of those. So this one has x squared, but that's okay. There's no y squared, there's no plus minus, so this is a function. To check if it's a one-to-one function, we look for any x squareds, plus minus, or absolute value. This has an x squared, so it fails the one-to-one function. It's just a normal one. This one does not have a y squared, does not have a plus minus, so it is a function. It doesn't have an x squared or a plus minus, so it's a one-to-one function. So this one's a little tricky. This one, no y squared, no plus minus, so it's a function. There's no x squared or absolute value, so it's a one-to-one function. We have an x squared. So that means it passes the function, but not the one-to-one, so it's just a regular function. Now this is a simplification. as you get more and more complicated, and as we get to chapter 4, we will go into this more detail, but this just saves us the problem. For this chapter, if there's a y squared or a plus minus, it's not a function. This one, there's no x squared, no y squared. This one has absolute value, so it's not one-to-one, it's just a regular function. This one has an x squared. X squared, it's not one-to-one, it's just a regular function. And plus minus, it means it's failing the function. So this is a relation. So a little bit of a shortcut, but it's hard to remember. That's the problem with it. At worst, try graphing things. Once you have the graph, vertical or horizontal line tests.